For those that are new to us, we are focused on trying to build community and bringing awareness to all these new technologies, from laser scanners to drones, point clouds, how they're used, creating models from them. And this webinar is working alongside Silvio here as a technology review, kind of looking at some comparisons and looking at accuracies. But the community of RCN really started with a podcast, having conversations with professionals, building this community. We started our first in-person conference 2 years ago, and webinars and educational content are another arm of that. And our goal is to continue having these on monthly, bi-weekly basis, with different technologies and different professionals. So we appreciate the support. And Silvio, thank you for joining us and being willing to come and share some of your findings and in some recent project case studies. So I'd love for you to introduce yourself, and then we'll roll into today's topic.
Hey, Matt, thank you so much for having me. I'm Silvio, director of RC Monkeys, and we are focused on capturing and documenting historic buildings, in the U.S. and hopefully outside of the country.
That's awesome. Mm-hmm. Well, thank you for joining us. So today's webinar, this is one of those things. Again, this is very community driven. The way this came about, I see Silvio doing some great work, and all of us are out here using these different tools, right? Nobody has every single tool and is using every single tool. I don't own a Matterport 3 yet. I have a Matterport 2, and so I understand Matterport. I don't have a Leica P series, but I have Leica RTCs. I have survey control internal, some others don't. So the goal of this community-driven collaboration and education is that when we come together, we can share information together that maybe not one person has. So I saw you doing some case studies, sharing some information about a recent case study you had done on a project where you scanned it with the Leica RTC, and you also have one of the new Matterports. And so you said, hey, this is a good time to compare the data and kind of figure out what is the accuracies. And a lot of people who run out and just buy one unit, they don't really know the true accuracy. How does it compare to other hardware? And what are those accuracies? What do they look like? So I think the goal today, and Silvio's going to share his presentation and kind of walk through his approach to a project he had using these tools. And we're going to actually, get in and talk about it, talk about field workflows, talk about some of the data processing, and get in and look at some analysis of accuracies. And, one other thing I'd like to point out is that our goal when we do these webinars is never to bash a technology or say something is, bad or not good. The goal is to highlight the benefits of each tool, right? There's a whole plethora of tools that we can grab from terrestrial scanners to iPhone scanners, right? But where do they fit? Where do we need to be concerned? Where do we need to, we need to think about when should we use which tool for what type of job? That is the goal of our webinars and the educational content we want, because we've seen a lot of the heartache of people grabbing the wrong tool and running out to a job. And they thought it was going to be accurate enough. They thought, and they delivered data to a client, and the client said, what is XYZ? And some of the users just don't know. So again, thank you again for sharing your findings with us today. Looking forward to digging into it.
Oh yeah, it's going to be a lot of fun. And we're on the same page. Whenever we buy a tool or rent a tool or use a piece of software, we just want to stretch it to its limits and understand what is it capable of, and can this be used to deliver the value that we promised to the client. If the answer is no, we need to look at something else. Or if we have some limitation in terms of hardware or software, we need to make sure that we don't over promise, right? So that's why we did this test. We just wanted to understand, having a new tool, what are its limitations? What are the some of the benefits that we can rip by owning one? And I would love to share what we discovered in that process.
No, it's great, and I'm looking forward to it. again, I like to just preface that in the beginning is that our goal is what's the positives of each tool? Because the other thing, a lot of people have even mentioned since us announcing we were going to do this is like, oh, it's not fair to compare a Matterport and a Leica. Well, really it's not, right? A Matterport is a $5, $6, $7, whatever $1,000 camera with LiDAR in it. And an iPhone, right, is a $1,200 camera with LiDAR in it. An $80,000 Leica RTC. Our goal here is not pointing out the flaws. It is what's the comparison? Because as people see cheaper price points, it brings in people who couldn't go out and buy an $80,000 scanner. The fear sometimes, and why we do need to dig into the accuracies, is at what point does that accuracy start to become an issue? So yeah, very excited. Go ahead and share your screen whenever you're ready. And
all right, we'll do that.
Everybody else who's listening, you guys are welcome to submit questions in the Q&A box as we're going through the presentation. You're also welcome to use the chat area. I'll be kind of looking at both of those as we go. We may interrupt and do some questions throughout the presentation, but we're reserving the end of the presentation for kind of deep diving into some Q&A. So thank you again.
All right, great. So as Matt said, the goal is to understand where this new tool, it's been on the market for what, 2 months, was announced about 2 months ago, and people started getting their first camera about a month ago. That's when we got our first camera, and I just wanted to see where does it fit on the spectrum of accuracy and precision, given that it does have a LiDAR sensor in it. And that is the reason why we purchased the tool, because of that LiDAR sensor and how that sensor improves the camera over the previous generation that has some limitation in terms of scanning in very powerful or strong daylight. So again, this comparison, or I don't want to say that it is comparison. We're comparing it to another tool like the RTC 360. Because that's what we had on site at the time when we conducted or did this project, as well as, it's a great mid-range scanner that provides good accuracy. So a good baseline that we can compare it against. All right. So before we get into looking at the camera, the data, just want to spend 1 minute to talk about who's RC Monkeys. What do we do? So we focus primarily on documenting historic buildings. We started the company about 4 years ago, and our mission is to preserve the American heritage through the as-built documentation for buildings built before 1960s. We work on various types of projects, from viaducts, lighthouses, a lot of lighthouses, churches. So, and I personally been scanning for, I'll say 12, 13 years now, started in 2010. I have done personally more than 700 projects, scan to BIM or just scanning alone. So just wanted to make sure that, we have the credentials behind, doing this comparison. So let's talk a little bit about how we use the Matterport camera on our projects. So what you can see here is one of our projects that we captured a few weeks ago. And the way we use the Matterport camera is as a supplemental instrument to capture all these 360 tours. And the first thing that we do when we get on the job site, we capture the Matterport tours, and then we walk the site. And we call this process reading the building. So we record a lot of information. Like for instance, right here we measured the finished floor. We use a more precise instrument. So we capture a lot of information that might not be just easy to infer from just looking at a point cloud. And where should we store all the information? So we needed a repository, something that would be contextual. So the Matterport tour, it was ideal place to do it with the help of the tags and the all the links and uploads that we can do to this platform. So again, this is the primary use of the tool. But we thought, hey, this thing has a LiDAR, so let's test it and see if we ever need to use the Matterport Pro 3 as a scanner. Can we rely on it? What is the accuracy that we can get from the sensor? They claim, or at least the specifications tell us that we can get plus minus 20 millimeters. But is that the case? Is the data noisy? So that's what we wanted to do, just to understand how the data looks when compared to another tool that we knew was accurate, and we got clean data. So the project that we will be using today, it is a church built in 1844. So I mean, probably not an old building using European standards, but for the US, it's quite an old building, about 1,800 square feet, very simple layout. So in my opinion, this was a good test. Was not a big building that would overwhelm the application or the camera. So the project is divided in four different levels. We have the partial crawl space. We have a ground level that is 1,800 square feet. So if you're joining from other parts of the world, we're using the metric system. That's about 200 square meters. And then we have a partial second floor, just a small balcony, and then a full attic with a steeple. So all of these spaces were captured with both the RTC 360 and with the Matterport Pro 3. All right, so let's talk a little bit about the field workflow and what was our impression working with this camera in the field. So, we talked about the previous generation, Pro 2 or other cameras. This camera is quite fast, about 20 seconds a setup. That's about 4 times faster than the previous generation, which to me was, quite fast, since it takes more time just to go to the camera and come back once you want to move the tripod. So in terms of the alignment, obviously we're using a mobile device in order to control the camera. There's no way you can use there's no touch screen or anything like that. So initially we wanted to test it with 2 mobile phones. We used a iPhone 13 and a Galaxy S9 Plus, so an Android device and an iOS device. There was quite a difference between the two. And then the last test that we did was on a last generation iPad Pro. And the difference between the older Android device versus the new iPad Pro was just, I'll say 20x. Sometimes it take a minute to align and process scans on the older Android device versus about 2 to 5 seconds on the new iPad. So definitely make sure that when you choose your mobile device to control the unit, use a newer one. All right. So in most cases, the alignment between scans or between setups worked pretty well, with the exception of trying to get behind doors, like in this instance, or just if you follow some of the instructions in the on Matterport's website, they suggest not to move objects around. But we have this instance, for instance, we have a narrow corridor, we have a very big door, and we need to close the door in order to scan behind the door. So we tried to close the door a few times, actually up to 10 times, and the alignment failed. It's a little bit silly that we, just by moving a door, and I know it's taking a lot of, let's say, square footage in this view range, but we do have 60-70% more surface space that we can use for alignment. However, just the application didn't like moving this door. So what we ended up doing, we have that small opening right there. We had to place the camera right between that door panel and the corner of this this corridor. And this is kind of what it looks like. I mean, you can see the door panel is out of focus, but this was the only way we can tie the space behind the door panel. So these are some of the challenges that we had to deal with. So hopefully the new updates of the application will address these alignment issues, since I assume the LiDAR data is a lot more powerful than what they were using with the previous generations. All right, so the other thing that you should probably, if you use Matterport, you're already used to this. There's not a lot of control over the alignment. So there's something that I would love to see in with the next few updates. Especially if you tend to stop and move around the building, you kind of, when you move your scanner or your camera, you're hoping that you're going to get a good alignment. Sometimes, it works, sometimes it doesn't. So you kind of hope things will go well. What I would like to see is the ability to at least tell the application what is the closest setup to the one that you're just recording,
which would be kind of similar to the scanning workflows, right? Like when you're using the RTC and you have the iPad, or even some of the other scanners, Trimble's or Pharaoh's, with their newer processes in the field, is you can, if one doesn't place automatically, just because sometimes math algorithms, whatever, they just decide not to place, and in those applications you can say, hey, this was the closest scan, let me move it close to where it should be, and then try to place, and then it fixes it.
Just to give it a hint, right? They're like, hey, we're working in this area right now. We're not at the other end of the building, right? And the other thing is the low light performance. So on the project that I just showed you, we scanned in the crawl space, which was pitch black, and then the attic. In order to prepare for those conditions, we used a LED rig that we clamped to the tripod, and some additional LED panels that we scattered around to get some good lighting. So we didn't have any issues scanning those spaces. But one thing that I thought, it's like, I wonder if this has a LiDAR sensor in it, does it behave like a regular scanner? Because we don't need light with a regular scanner. So actually this weekend I put it to the test, and what you see here on the screen is just a small portion of my house. And it was about 7 a.m. So we didn't have, the sun was not up yet. So we started capturing the one part of the house that was lit. And then, as you can see, starting with station 14, we started going on this hallway, and then into some rooms that were completely dark, no light. And actually the alignment worked very, very good.
Good.
And it behaved exactly like you would expect the scanner to behave. It didn't need any artificial or natural light in order to make these align. So this is a snapshot. I mean, it's kind of dark, but this is what the preview of the image looked like. So you can see a little bit of light that was coming through or around the window shades, but I couldn't see much in those rooms. So that's good news. If people actually want to use this as a scanner, we know that they don't need a lot of light. Or if they do have to traverse across a poorly lit hallway, they can do it without worrying about alignment.
And so another short explanation to that, because even people that are looking into having scanning done, they ask that question. They're like, how do we deal with scanning in the attic if there's no light up there? So the reason he's bringing this up is the previous Matterport didn't have the LiDAR, and so it required good lighting in order to map in an area because it's using the photos, right?
I think it's using also the infrared. So I'm not sure exactly if it worked exactly the same.
Okay.
Yeah.
But the reason that laser scanning, or now with the LiDAR, the reason those work in the dark is that, yes, they take images, and so your colorized data or your pictures are going to be dark because the space is not lit. But when you're laser scanning, it's a laser. It is light that is doing the measurement. So it works just as well in the dark as it does, or even better than in bright sunlight, because the laser is still what's doing the measurement. So now this version is expanding what you can do with the Matterport camera.
Yeah, because I assume with the previous generation, if you did have like a large space, given the range limitation of the infrared sensor, you would not get good alignments.
Yeah.
And since this sensor, the LiDAR sensor, has a range of up to 100 meters, you can rely on it for alignment.
Awesome.
All right. So let's dig into some of these scans and see how they look. All right. So initially, we'll look at some individual scans, and then we will look at the overall alignment of the registration done by Matterport, and then compare that with the registration of the RTC 360 data. All right, so let's take a look at some of these Matterport scans. So what you can see here, this is not a 360 image inside the Matterport platform, but rather this is the quality of the image that came with the E57 that we downloaded. So we imported that E57 into Cyclone. And this is amazing, to be honest. I wish the RTC 360 had a similar image quality. And then we switched to the point cloud. So it is scarce. It records 100,000 points per second. So I think each scan was about 5 million points. But the thing that we noticed, I was like, okay, let's try to extract this target. Like, we get this exception reason. We don't have intensity data. So I'm going to pause it here for a second. So in order to extract these checkerboard targets, black and white targets, to tie it to control or to use these as spatial constraints, you need that. The reason why they're black and white is because you get quite a huge difference in intensity values, and those are the ability of the light being absorbed by a surface, and then it returns a value back to its source. So in this case, there's no intensity value that was baked in this E57. So from what I noticed, the data is structured, which means it has normals. However, it doesn't have intensity. So maybe that's something that was omitted when the files are written, and hopefully it will be introduced in the newer versions. This will be critical if somebody would like to extract some of these targets. You might say, yeah, maybe we can put a point right there at the center of that target. This target is about 1.5 meters away from the scanner or from the camera, which makes it easy. You might have a point right at the center. However, if we have targets that are further from the camera, the resolution will be smaller, will decrease, which means you have less points on the surface of the target, which means the probability of having a point right at the center of the target is pretty minimal. So then you need to let the algorithm of whatever registration software you use to determine where that center is, and you need those intensity values. So this might not be important for some, but yeah, if you do want to use some targets for some projects, that would be. This is how we register the Pro 3 data to the register through the RTC 360 data. We use these targets. It was much easier than to do cloud to cloud. All right, let's move on. And then we're looking at the scan, and then we zoom out, and then this was something that we were not expecting. We see these ripple effects, and they're all perpendicular to each other, and they're much noticeable when you're closer to a surface. We were about, again, 1.5 meters, so that's 3 to 5 feet away. You can see it on the ceiling, you can see it on the walls. It is everywhere. So we thought, okay, let's take a look at this data and do a few horizontal and vertical slices to understand how are these ripple effects affecting the accuracy. So we did a horizontal slice through the data, and we are looking right now. This is a plan view, and we're looking at the data, and you'll see that instead of being a planar surface, is quite wavy. And the noise, if we want to call this a noise, is some people might not accept it as good data. So just by looking at this, it looks at the precision of the measurements are a little bit off. And once we're going to compare this to the RTC 360 data, we will see that the average of the entire scan is within that plus minus 20 millimeters. So you can see that the further away you're from the scanner, you might not notice those the waviness in the data, but the closer you are, those are more pronounced. So let's take a look at a vertical slice, and this is a 2-inch slice, or 50 millimeters, and this is supposed to be a planar surface again. There's a lot of noise, and this is very interesting. Like we were wondering why we are getting these ripple effects in the data. So you can see it on the ceiling as well.
And one thing I'd like to just kind of point out is, again, without doing an overlay against the RTC or any other terrestrial scanner that, again, yes, they're not on the same level, right? The Matterport is a few $1,000 entry-level camera that can get some point cloud. But when you compare it against something that has very high precision, that's when we can actually look and see what the data is really doing. Because if you just buy this camera and you just scan it, like if this was your camera, this was your job, you went to document this building, how do you know how accurate it is? Or how would you know if those ripple effects actually exist because the surface of the building is, weird, or if it's something to do with the data? So I just wanted to point that out, because even as you initially look at this data, it's like, man, this is actually for how entry level and the affordability of it, this is pretty sweet. Like you could open this up and throw together a rough model or drawing of the rough floor plan and layout of this building. But where it really matters is, again, we reverse engineer, like, what are we using for the data for? How accurate do we want it to be? And then how does this actually compare? So when you get into showing the two data sets, I think that's what people is a little more eye-opening.
Yeah. And I guess the RTC 360 data is like having survey control, right?
Yeah.
In a way, right?
Yep. In this comparison, yeah, it's really the baseline we using for that comparison.
All right. So what we have here is an RTC scan that was captured from a similar location, overlaid or registered together with the Matterport Pro 3 data. So we're going to take a look at some of the same areas and see how the data compares. So we can see some differences here. And especially, again, the closer we are to the camera, we see that noise, if we want to call it noise.
So but dark blue is the Leica RTC.
Yes. Yeah, I should have mentioned that. I mean, yeah, the dark blue is the RTC, and then the cyan, that's the Pro 3 camera. So overall, I mean, you can see that it fits pretty good to the RTC data, right? So just overlaying these two data sets, it allows us to say, okay, if we ever have to draw or model from this data, where should we put the face of a wall? Should we put it right in the middle of the data? Should we put it in front or behind the data, right? Obviously, if you're modeling from a point cloud and there's noise, you try to kind of be in the middle. But you quite wonder, right? Where should we put it? And but we're not always going to be right. I mean, we see here that the actual wall surface is in front of the Pro 3 point cloud. And then when we look at a vertical slice, I mean, you can see the difference. There's quite some difference in precision. And yeah, once you zoom in, you're going to start to see those differences. So even the ceiling, you can see that waviness. But still, overall, I think is a very good match. I did not expect to see this good of a match.
Yeah, and again, that's the thing we like to point out is like the overall fit is decent, and maybe people who are looking at their first unit that gets them into capturing the building, if they're not promising a very high end accuracy deliverable, and it's something that fits a certain need, it's turning out that it's like it is a good unit. But for companies or construction firms that are asking you to come out and deliver a certain accuracy, then you need to understand this level of detail and where it really is. I think one of the things, as you dig into this more, I know there's some videos that show like the inside versus the outside, and there's some areas that error compounds quite a bit. And I think the biggest takeaway I've seen from like some of the Matterport data, even when I did the iPhone tests, is that it can come out good, but it also can come out pretty bad. It feels like it's just not quite as consistent or as reliable, and it may really have to do with like the environment and the feature types and the things like that. But I think this does show quite a bit to those who haven't seen or done any comparison as to it's pretty decent, but there are things to keep in mind when you're looking at using it for actual measurements.
Yeah, and I think Matt, you just said the two magic words: reliability and consistency, right? So if you are or if you add this to your toolbox, you want to make sure that you can rely on it, and understanding in what situations you might accumulate some of those errors, I think is critical, right? All right, so Matt mentioned differences between interior and exterior. So this is what we have here. We have an exterior scan, and again, I cannot explain this. I don't know what's happening, behind the hardware and software, but we get some of this weird, I don't know, it's like the data is being sucked towards the unit. So we get this everywhere outside. And just wanted to mention that day was a little bit foggy. I mean, maybe the visibility was about a mile, but there was some moisture in the air. I don't know if that moisture can actually affect the accuracy of the instrument, but that's what we saw. A lot of these corners and a lot of these surfaces were just I felt like they were just pulled towards the scanner. So you can imagine that if you're doing a cloud to cloud alignment registration, all of these inaccuracies, even though they're small, they will affect the overall registration.
Yeah.
All right. So let's take a look at the alignment. So first, we will take a look at the E57 that was generated by the Matterport platform. And then we will compare that to the overall registration that we did in Cyclone Core using the RTC 360 data. So I want to pause here for a second. So you can see this is just an isometric view of the point cloud, the Matterport E57 point cloud. There's some noise. You can see some of those bubbles here on the bottom left corner. There's some noise, but this is a improved version. The first version that we got, it looked like just an explosion of points. There was some moisture in the air, and apparently with the latest update, they were able to remove all of that noise that apparently was created by fog and moisture in the air.
Which I'd love, because you even just mentioned that, I'd love to just reiterate, that Matterport is continuing to work on improving things that they're finding. So, right, Silvio, even since you processed this original job, Matterport updated some processing in the back end and a new E57 that was cleaner and looked better. So they are doing a pretty good job at trying to improve. That was a pretty cool thing to hear from them.
Yeah, and this apparently that new update was specifically designed to work with the Pro 3 data. All right, so let's continue this. So we're gonna cut a horizontal section through the building. So we have about 120 setups, or big, they're called sweeps. And we colorize every single station using a unique color. So you can see there's a lot of noise, but again, this is the main space. It's about 1,600 square feet, and it did a pretty good job aligning. We didn't optimize this in Cyclone with just a straight import, and we were able to look at the data. But then once we start moving outside of that space through one door, we start to see some misalignments. Again, it might be because of the noise, and especially the exterior scans. You can see it has some trouble there aligning the all those corners and all of those facades. And so this is something that we need to think about. This was just a small project. I don't know how the alignment will look like if we're trying to do a 10,000, 15,000 square foot project. I mean, you can see a lot of differences here on the z-axis as well. And the other thing that I want to mention is that when we initially looked at the alignment generated on the mobile device, it looked pretty bad. I mean, when we closed the loops, the corners were feet away. So, but once it was processed on the Matterport platform, all of those were resolved within reason, obviously.
Yeah.
But this is what we found.
So pause there. You still, you look at this, and again, this is kind of the handoff of where people have to understand how to test this, or how to look at this, or know that this is how off the data might be. Because when you start looking at use cases of scanning, right? If you're scanning, or you're coming out to use a Matterport or an RTC for the interior of this building because the client wants the rough square footage, like that's one use case. I would initially say this is accurate enough, because usually the building, they're not going to care if it's 1,500 square feet or 1,505 square feet. Like it's close enough that it's going to be there. Like we're within a couple inches. But what happens when you buy this Matterport and now you're telling people you scan, and an architect asks you for the outside of this building, and somebody's going to hand that data off to someone else who's wanting to design something to install on the outside, and they're going to fabricate this panel. And you have to understand, where are the use cases that the potential of this misalignment or accuracy is okay or not okay.
Yeah, and the other thing is, when you draw this, if you do have to use the Matterport data to create an elevation view, for instance. So if we look at, we have this fascia right here. This is a wood profile, and or we have the soffit. It's like, which one of these lines is the actual elevation, right?
Yeah,
we don't know, right? So you will have to introduce some error, and you need to understand what is that error, right? Is the going to the level of accuracy specifications published by the USIPD, right? You might say, okay, the measured accuracy is X or whatever that is, and the represented accuracy is Y. So you need to understand the difference between those two levels of accuracies.
Yeah, and understanding when is that okay and when is it not? Like this project specific, if I initially saw a data set like this, I would say, okay, well, but what was the field procedure used? Because even terrestrial scanners, someone could take and go out and do a poor job and come out with something that looks like this.
Correct.
We see people misalign registration all the time. But knowing that you're an experienced laser scanning professional, and you did, I think for this size of a job, you did quite a few setups. So I think that some of the errors and inaccuracies we're seeing aren't from workflow and from not registering it well or not doing enough Matterport setups. I think some of it has to do with the fact that it's just lower end, accuracy in general for the hardware. And if you have 100 scans that have a certain amount of error or shift or waviness in them, by the time you register 50 or 100 scans, then it's not going to come out looking like a single line. This is the outcome of a lot of scans with that accuracy.
Yeah, and the other thing that I want to point out is we unfroze the registration that was generated through the Matterport web application, and we tried to optimize it using Cyclone and Register 360, and the result was worse, to be honest. All that waviness in the data just made the algorithms. We changed various parameters. I think I tried like 10 or 15 times different types of parameters to make it align better, and it worked well on the interiors. But once we moved outside and we tried to close the loops, just the errors were too great.
Yeah.
So what we're looking at here is an overlay, or we registers together the Pro 3 registration and the RTC 360 registration. What you see in red, that is the Pro 3. What you see in green is the RTC 360 data. So we just wanted to see, okay, how they're claiming plus minus 20 millimeters, but that is the accuracy for one station, right? One scan, and that doesn't count for measurement precision. And if the precision is off, like we see those ripple effects, we see the data being pulled towards the scanner. How is that low precision? How is that affecting the overall registration? Are we still plus minus 20 millimeters, or are we accumulating a lot of error moving from room to room, going outside of the building? So you can see that we see some differences, especially on the exterior scans that are, I would say, closer to 3 inches. So that's something that we should keep in mind, that if we're using this data, we need to understand how is the data registered and what is the accuracy for each individual scan. And again, looking at a vertical section here, it is quite, there's noise, but for that big space, it is spot on. So it did quite good. If you don't need to extract profiles or details, and just to get like just basic floor plans and sections and elevations, this would work well. And again, you just need to make sure that instead of delivering an LOA 30 plus minus 5/8 of an inch model or drawing, you just have some looser specifications there, and maybe an LOA 20 or 10 is more suited for this kind of deliverable. So yeah, this is kind of how the data looks when we overlay the two sets together. So I mean, to be honest, if I were to use this in just a small space, just to get some overall measurements, I'll be very confident using it. So would I still buy the camera after looking at the data and seeing what it can produce? Yeah.
That guy looks like he's ready to give you his money.
Yeah, exactly. I mean, look at that smile. It's still like, I mean, it's a great camera. We didn't buy the camera for the LiDARs, like to scan with it, or for the tours, right? But if I were to scan with that camera, can I do it? Maybe, but I need to understand what the limitations are. Can I scan a whole building with it? I don't know. If they fix some of these issues that we've seen, maybe. And some of the improvements that I would like to see, maybe with some firmware updates, I would like to see a refined precision of the instrument. I think that's how do we get rid of that waviness in the data, those ripple effects. I think that's a question that I have. Is it a hardware problem, a software problem? Can we address that with a firmware update? The other thing is how do we remove some of the noise? They did a great job removing the noise caused by certain particulates in the atmosphere, but there's still some noise with the exterior scans when you're dealing with foliage. So refining that noise reduction, I think, will be an improvement in the overall quality of the data, and I assume the registration as well. if you're not dealing with a lot of noise, the cloud-to-cloud alignment will be much better. And then they should definitely bake those intensities. If this unit works like all the other scanners, there's no reason why that column, the intensity column, shouldn't be in the E57 file. So please bake the E57 with the file that's being delivered. That will help some people that are using targets for alignment. And then the last thing is, if we have some extra control when it comes to the alignment, so using the Matterport app, that would definitely improve the process. For those, there are going to be some setups that they won't align. So just pointing the app in the right direction and telling it, hey, we're scanning in this part of the building, and try to look for alignment between these scans. That would help the overall process and the outcome of these kinds of applications. So that's what I had in terms of the analysis. I guess now we can open it for questions.
Awesome. Yeah. Well, let's go through a few. I know we've got some submit here, so I'll read through a few and we'll see what we can do here. Let's see. Let's start with this one. So, and we kind of answered this a little bit, but are we comparing a single RTC scan to a Matterport scan? What happens with the registered Matterport data? Does the accuracy get worse? So I think it was probably kind of answered throughout, but if you want to give a response to that.
Yeah, so we compared both instances, right? Scan to scan, captured roughly in the same location, and then the overall registration is compared together. And we did about, I would say, 120 RTC setups. And you might say, yeah, that's a lot for 1,800 square feet. But remember, we had like 4 different levels.
Yeah,
attic, crawl space. I mean, we're not talking just ground level and exterior. And we had with the Matterport, we didn't scan for like efficiency. We didn't capture these setups the most efficient distance, but we wanted to increase the distance so we have good photographic information to model the building.
Yeah.
So
perfect.
I think we had about 150 setups for the Matterport, I believe.
Yeah, which again, I think this was a great project to use as a study because it is small, but it has a lot of unique features. You did inside, outside, multiple levels, but the square footage is small. So, any of the complexities we looked at on this review, the bigger the project or the more complex the project, the more that type of error or things would typically compound.
Yeah. There are no windows that we can. I mean, all the windows were boarded. So if we add windows in the mix, I'm not sure how. I know we can flag those surfaces while we're scanning, but I haven't tested that condition to see how it works.
Awesome. Another one. How easy or not was it to repeat the concentric circles from the Pro 3 when it was closer to the walls?
Oh, it happened every time.
Every time?
Every time, on every station.
Every station. There's the answer. Was the RTC data registered manually?
Manually?
Not exactly sure what that means, but I mean it probably would have been registered.
We always register the our scans manually. I mean, we use the pre-alignment in the field, but then we go through the registration and we add targets if we need to, and we add more cloud-to-cloud constraints, and we make sure that we massage everything to be within the level of accuracy that's specified in the contract.
Yeah, and even in like the review of the data showing here, you as you're slicing down and showing the profiles, if there's misregistration in the RTC, we would have seen that too. Because you would see multiple lines. So, and honestly, I just throw that out while we're on the topic. I think that's one of the biggest missed steps by a lot of companies scanning is ever just trusting what results come out from a report or a green light or anything like that. You should, every single project, your last step should be slicing through like that and visually looking at your lines. So while we're on that topic, that's a step everybody should be doing.
And not only that, I've seen a lot of your posts, Matt, on LinkedIn, where you show these super simple rectangular spaces like a warehouse or just a floor plate of an office building open, but you still add all those redundant links between the maybe you did it for to have like a nice pattern.
Yes I did have one that had a nice pattern in it.
but all those things are important. Don't just rely on the links or constraints that come from the Field 360 app or from the VIS, and also make sure you close loops, right? Horizontal and vertical, as many loops as you can.
Yep, totally. Here's another one. Looks like the Pro 3 does not capture shingles.
Oh, it does. That was in a different E57. I just didn't want to pay for another $100.
There you go.
I just, it was, there were two different spaces or two different projects on the platform.
So a follow-up to that one was, another specific question might be, do you have information or experience on the Pro 3 and how it handles black or reflective surfaces?
Actually, I did not test that out, but that's a good question. I know that the BLK Generation 1 has some challenges capturing black surfaces. With the second generation, I think that improved. But that is a really good question. We haven't tested that out.
Yeah. And I think that, it leads to, it'd be great. Again, we look at this as one comparison. We would love to do more of these. We'd love to test each piece of hardware with different people on different types of applications, comparing different accuracies, what the accuracy is with or without control, what's needed for floor flatness. There's so many aspects to these tools and what you do with the data that a lot of people in the industry they don't have the time, they don't have the gear, they don't go out and trial all these things. And I think it's something that we as a community, there's a lot of people on this call that have some of these tools that work in different industries. And so sharing information like this is one of the most valuable things I think we can do collectively. It helps us all understand, is that a tool I should consider? How can I use this one? That one was proven that XYZ does or doesn't, So I appreciate you being willing to share as well. And let's hit a few more questions.
Before we move to the next one, there's another thing that I would like to add. Another test that we haven't done is regarding levelness, right? Mm-hmm. So, a lot of people, they use their instruments thinking that data is level. Not even the RTC 360, doesn't have a dual axis compensator. It has an IMU accuracy is 18 seconds. It does have some software correction that it improves the levelness, but it's still not level. And that's one thing that we haven't done. We had some of the targets set up with a level in that building, and we can check to see, okay, if we take the registration that came from from Matterport and we extract all of those targets, do they all have, I'll say plus, the same elevation, plus minus, what is that tolerance? Because if we see, 5 inches of difference between targets that are opposite in the building, that's concerning.
Yeah.
Right.
Yeah.
And I don't know if, what kind of sensor this unit has in it. I haven't done any research to see, if it has an IMU.
Yeah.
What is the accuracy of that IMU?
Yeah. And honestly, one of the reasons I post about survey control and stuff so much is that is a consideration that people need to look at with every piece of hardware. If you take a Navis or an RTC or a P50 or a Faro scanner or a Matterport, what is the true accuracy, both horizontally and vertically? And just like we did here with the RTC, we used it as the baseline to then take the Matterport data and say, okay, the RTC is pretty dang accurate, so we're calling that the baseline. If we didn't use that baseline, we would have no idea how accurate this Matterport data is. And sometimes the same goes for these other tools, and maybe it's a smaller level of error, but without a secondary verification of control, whether a P-series scanner or a total station. If you go out and scan with a Navis, or you go out and scan with a RTC or a Faro, how do you know if there's error built in horizontally or vertically across larger projects? That's one of the reasons the survey control can become so important. If your accuracy need is tight, that's something a lot of people need to consider with different tools.
Yeah, and not only if your accuracy need is tight, but also like for this building in particular, it's a small building. But when we slice the building, we've noticed a 2-inch uneven settlement on one side of the building. And this was for maybe on a 2-foot length, right? So you might wonder, is that the data or is that the building? Because if that's the building, that is concerning. You have a steeple right in the area. So that 2-inch uneven settlement, now it transfers all the way to the top of the steeple, and you might have out of plumb conditions that are 4 or 5 inches that will affect the building the new structure for the steeple. So knowing if your data is true, is level within a certain level of accuracy, it is quite important when you extract the information and you communicate it to the structure engineer or the architect to make decisions with.
Yeah, we'll have to dig deep into that another time. It'll be a whole webinar worth. A couple more questions. Does the Matterport 3 have settings on it? Like, can you change how it's different power levels or anything like that? Nope. You just turn it on.
Plug and play. Go. Yeah, turn it on and start scanning.
All right. What file formats can be exported from the scanner? That was the question. So I'm going to assume they're asking about Matterport, but
you don't you cannot pull any data off the scanner directly. It's not like you download the proprietary raw scans from the scanner. You just upload your project from the app to your Matterport account, and then they do some voodoo behind it. I don't know exactly what's happening, and they make them look better, and they send you a link when it's ready. You can pay $89 to download the E57 if it's not already added to your account.
And the only file option on the LiDAR portion was the E57.
Yes, I think so. I think so. Yes.
Okay.
But also, I think the guys from Matterport mentioned that, hey, we should try the what is the other one? Matterpack.
The Matterpack, yeah.
Yes.
And so that's the point cloud that's created from the photogrammetry.
Correct. Yes.
So for people that are looking at using it, you can kind of look at both files. In fact, I know we were talking beforehand. We said maybe it'd be cool to do another and even just compare the differences between the Matterpack photogrammetry point cloud that comes from Matterport, maybe even using the 2 version, and then the LiDAR file that comes out of the 3 and see what's the differences or comparison there. While we're on that question, have you noticed differences in the picture quality from older Matterport to the 3?
I did not know.
Didn't really notice. Okay. Here's a fun one. This one's more in general. With Matterport getting closer in terms of accuracy, do you think it will put pressure down on other laser scanners in general?
I don't know. I mean,
I know my thought.
I mean, when you think about it, scanners in general, they became cheaper. Even though you might say, hey, a P50 or a P40 has been $120,000 for many years.
Yeah,
but that still is the same number, $120,000. I mean, in 2010, when I started using the P20, the previous generation P series, $120,000 was worth more than today. So in a sense, the scanners cost less.
Yeah.
Right? Because the purchasing power of the dollar, at least in the US, is less than 12, 15, 20 years ago. Will it put pressure on probably, I don't know. Probably not.
Yeah.
Because there's if I were to develop a product, I would just target a very specific niche, and I would just keep the pricing to reflect the needs of that niche.
Yeah.
I'm not going to try to compete with a tool that is designed probably for a real estate for a real estate market or for entry level AEC individual. So I think
Yeah.
they're competing in completely two different markets.
Yeah, that's my biggest response is that when I see new tools come out, again, when the iPhone first came out with LiDAR, I ran out and bought one. I have a couple webinars I did to show what it captured. I compared it to terrestrial. We still have those webinars available if anybody wants to see those as well. But the biggest feedback was, from my perspective, is these tools that are coming out, they are a cheaper price point. They're not the same level of quality and accuracy on large jobs. What I see these tools doing, the phones, the Matterports, the 360 photos, the 360 videos, they're expanding capabilities. It's letting us do something that, again, maybe terrestrial scanning is too expensive to go out and do a bedroom, right? Because you're wanting to measure. Like, I see it as being able to do cheaper price points that lets a volume of the market that was not really able to support scanning yet start getting into it. It doesn't replace the need for terrestrial scanning. You're never going to take the Matterport and go do an oil and gas facility or again a building like you just showed us. If your goal is fine accuracy and precision measurement and historic preservation, and so it all comes down to those use cases. And I think the variety of tools is helping us expand the use cases, not really put too much pressure on each other. Maybe it takes 5% of the market that, terrestrial scanners could have had in a lower end area, maybe by Matterport being able to provide it, but it's not replacing the majority of scanning applications.
Yeah, I mean, it's the same as, if they improved the accuracy and precision of the instrument, would I sell the RTC to and then just use the Matterport? No. I mean, it's the same with the VLX, right? From Navis. It's like, oh, are we going to sell our terrestrial scanners because now we can capture between 150 to 200,000 square feet a day? No, we're going to use them together in hybrid workflows and get the best out of both.
And I think that that's something that people just need to keep in mind. Most companies who are trying to do a diverse set of projects own multiple. Like I said, we have a Matterport, we have an RTC, we have a VLX. They don't replace each other. If your goal is to only own one unit, then the best thing you can do is not really step way too far outside what its capabilities are. If you want to buy a Matterport, just don't go try to use it on projects that need high accuracy, because what it does is it hurts you, it hurts the client, it hurts the industry by not meeting up to the expectations of what was needed on that job. So that's why I think this education is so important, is there's not a lot of people showing these comparisons and talking about this use. But in order for the industry to adopt this on a wider base, we have to continue delivering good quality, not using the wrong tools, and kind of meeting those expectations.
Yes, and the same. Talking about the project needs, we're constantly working on the same project where we need to monitor the deflection deviation of these smokestacks, and they're only 280 feet, right, tall.
Mm-hmm.
Could we have used the RTC? Maybe, but since I need high precision in measurement, it's like, why risk it?
Yeah.
Right? Use a P series, and you're going to get much better and much cleaner data at that distance, even though we're not close to the maximum range of the RTC scanner.
Yeah, absolutely.
Mm-hmm.
Another question: what would you guess if you were going to tell somebody the approximate accuracy to expect using the Pro 3, horizontally, vertically?
I mean, I think when it comes to the accuracy of each individual scan, I think it is within that plus minus 20 millimeters. If you're kind of averaging and when you look at the noise, just average that noise, I think we're within that plus minus 20 millimeters. But when you're talking across a building, all of those small inaccuracies, they're going to add up. All that error is going to accumulate. So I cannot tell you what is the global accuracy of a registration at a building scale.
With what we saw on this case study, would you say plus or minus 2 inches?
I mean, it could be plus minus half a foot.
Yeah.
Right. Who knows? Well,
So the people, there's a couple questions asking about accuracy because everybody wants to know that. So I would say, because a couple of the questions have been plus or minus an inch, plus or minus a quarter inch.
Mhm.
And I think the overall feel based on this case study is your outcome with it on this project would not meet either of those. You would, if the only data set you had was the Matterport data on that building, you would assume it's more plus or minus 2, 3, inches. There's
probably
between
plus minus 2 to 3 inches.
Yeah.
Right. And if the registration looks better with maybe previous new versions, then I would say, yeah, probably accuracy has improved, and we would say, yeah, we're getting plus minus 2 inches, plus minus an inch over the length of an entire building. But until I start seeing less double lines, I cannot say for certain what is the global accuracy of a registration. Again, we're talking about registration at a scan level versus registration for the entire project, which are two different things.
Yeah, and again, I think just on that note, personally, I'd just like to say for everybody listening, for Matterport, for everybody, is that our goal here, again, we are just presenting what was found right now, the way you scanned it, and the other thing I'd say is, look, someone might take it on a different building and get different results. Maybe they'll use it on the exterior and there's other features apart from the building they were scanning, and maybe they come together cleaner. So I would say that everything that we've shared today can be taken with a grain of salt, right? And I suggest people, if they really think otherwise, like, do your own tests. Rent a unit. This is a case study. When you do a case study, that is that data set from that project that you tried, that this is the findings. And our goal in sharing it is that personally, as professionals, we feel like this is what our outcome was. And so we feel that it's okay and it's honest to share that with the community and say, here's our findings. Take that as you wish. If you feel comfortable, you're good enough, buy one if you're using it for mapping. If not, know the reasons we buy it. We're using the Matterports for really clean virtual tours. The imagery is amazing.
Oh, yes.
The imagery is so good.
Mm-hmm.
So just take everything and kind of make your own decisions. And if you guys have questions that aren't asked here, again, we're very open individuals. You're welcome to connect with us, send some messages, whatever. I think our goal is to continue to help educate the industry in whole, and try to help people avoid, costly mistakes that we've seen many of out there over the years. Any other thoughts there, Silvio?
No, I think covered pretty much everything.
Right.
Any other questions?
I think that was the majority of them. There's a couple more that I think might take a little more explanation and follow up. So if any of those questions we didn't get to, we will do some follow up with you all. Definitely appreciate everybody coming in. Let's see, one more just came in here. Would you use the Matterport for forensic data capturing, like accidents?
I know that for those particular scenes, right, you need to calculate trajectory of, So I don't know. I mean, I've heard people using the BLK but again, it's completely different data set.
Yeah.
I'll probably not.
Yeah.
Probably not.
Yeah.
I mean, if you just want to take beautiful pictures, yes.
Yeah. Yeah. Usually for something like that, I would say I'd take the next level up as the minimum because, something really unique about forensics is that you typically only have one shot at capturing that data. So you want something like we talked about earlier. You want something repeatable, reliable. Like you want to capture that data one time, capture everything where it is with high level of accuracy, because you can't go back. You can't, put the car back where it was in the accident. You can't. So you get one shot at it. All right. Well, I think this was great. Lots of interest, lots of questions out there. Thanks, guys, for joining us. We would love suggestions as well. One of the biggest things I'm trying to do when we plan out webinars, we plan out educational content, is hearing from the community of what are your pain points? What are you struggling with? What types of data or comparisons or tests are you interested in seeing? Because then we can work with people like Silviu and talk about, hey, do you want to do this together? Can we collaborate? If there's others of you in the industry that want to collaborate on a project, you have a comparison of your own of different, data. Let's talk and let's continue to pull together. I'll give one last plug for our conference that we're starting to do every year. Anybody that wants to come out, we are planning to have that back in Boise in October of 2023. We'll have some announcements up on that starting here in December. So feel free to stay in touch. We will send a follow-up with information on how you can reach out to Silviu or RCN team, and we'll go from there. All right. Thank you so much, Matt. All right. Yeah. Thank you again for joining. Thanks for sharing. And thanks everybody who tuned in live and those watching the recorded webinar. We'll see you again soon.